Welcome back. In this section, we are going to talk about machine learning versus AI engineering. Are they the same? Are they related? So let's look at that. So the precursor to all these data models that we have, the artificial intelligence, chat GPTs, what we had was machine learning. So machine learning also came out of big data. So if you look at the last couple of decades, there was a lot of focus on processing large amounts of data. Even before we came to AI, we were trying to make sense of large amounts of data. So if you look at credit card transactions, for example, we as a as if I'm a financial expert, I would want to look at all this huge amount of transactions that are happening. I want some insights on what type of purchases people are making. I'd like to know which are fraudulent transactions. So many possibilities. So the whole idea of sifting to huge amounts of data required setting up data pipelines. So as the industry set up data pipelines, we started to understand how these data are interrelated and what it means. So eventually it led on to a section of computer science called machine learning. So what that means is we use the same data pipelines, the similar learnings we got from big data, and we started building something called as machine learning pipelines. So machine learning is all about collecting a lot of data, labeling them, cleaning it, and processing large data sets into something that is meaningful. So the next natural iteration of machine learning was AI engineering. So in short, machine learning and AI engineering, they are related, and one is not the same as the other, and one cannot exist without the other. So engineers trained lots of models on this data. So we learned how to build huge pipelines, how do we scale, how do we accept millions, even billions of data points, how do we process, how do we store them, all of these things. So AI engineering evolved naturally from that base. Instead of working with a limited or a specialized data set, engineers began using these foundation models, which are trained on this huge amount of data types, including text, images, audio, and video. Another important point for the advent of AI is also rapid improvements in hardware, especially GPUs and TPUs. It made it feasible to train models on a massive scale. What once required huge supercomputers could now be accomplished in commercial cloud environments. So AWS, Azure, all these cloud providers, they also served a very important step for us to reach today's AI. So opening the door for a new generation of developers and researchers to build huge data models which can be used to build artificial intelligence. So that being the background of how AI engineering came out as an offshoot of machine learning, which itself came out as an offshoot of big data and so on. So now let's look at the two sides of AI development. Now that we know that it's all based on data, today if we do AI engineering, this is 2025, what is it that we do as AI development? So there are two sides of that. One is model development and the other is application development. So let's look at model development. In brief, this is mostly the domain of researchers and machine learning engineers. So it involves first handling large amounts of data, which means you clean up the data, you set up pipelines to process huge amounts of data, then you design and train models, you construct and curate data sets. You may not want all the data in your training model. You may want to clean it up a little bit, make it very specific to what you need. Tuning hyperparameters, optimizing inferences, because the model does not always generate output that you want. So you may want to tweak it. Evaluating performance and fairness. All of this is model development. So this is one part of AI engineering. The tools of the trade for this kind of model development is frameworks such as TensorFlow, PyTorch, Hugging Face transformers, which basically enable the building and experimentation of new architectures for models. So that is model development. The next part is once these models are in place, or at least some foundation models are in place, we have application development, which is equally interesting. This side is closer to traditional software engineering, but adds an intelligence layer on top of it. It involves selecting the appropriate model for a use case. You may have models which are tuned for text, some which is multimodal, like we talked about in previous episodes. A lot of varieties of models, some which are trained on huge data sets. You may want a specific type of data set, all of those things. And then for application development, you also want to benchmark and evaluate performance of one or two models that you select. Then we also go into designing prompts and interfaces. If you are going to use the model as a chat interface, you may want to spend some time in designing the right prompts and integrating the model with APIs, server-side components, managing persistence, storing and organizing AI-generated data, and finally deploying and scaling of AI services in production. In many ways, this mirrors the evolution of web development from back-end logic to front-end experience, but now infused with a lot of adaptive intelligence. This is very similar to full-stack development, but with a new area, which is basically this adaptive intelligence that I'm talking about. So those are the two primary ways or primary areas of AI development that's happening. We have model development and we have application development. And then there is a gray area where people use custom models and build applications on that, or vice versa, anywhere on that spectrum. These are the two ends of the spectrum. So with that in mind, a new kind of engineering is kind of emerging, AI engineering. This sits right at the intersection of software and cognition. It combines the rigor of programming with the fluidity of learning systems. Instead of writing strict instructions, engineers now guide systems that learn from experience. It's a very interesting, fascinating shift from deterministic code to probabilistic reasoning, from logic to learning, from programming to prompting, all of those things. And at the heart of it all are multimodal models. Systems that remind us that intelligence, whether human or artificial, is rarely one dimensional. Okay. So we began this journey with a simple idea that models predict the next token. Now we see those tokens could represent a word, a pixel, a note, or a sound, each adding to a tapestry of meaning that the model learns to interpret. So the next time you interact with a chatbot that can describe an image or a tool that generates music from text, remember you are witnessing the early stages of a system that doesn't just process data but synthesizes data but experiences the world through multiple senses. That's the true essence of multimodal AIs. We are one step closer to understanding not just language but life itself. In the next episode, we will dive deeper into techniques of building these models and how do we use it. So, thank you for listening. Come back for the next episode.